Find the slope of a line perpendicular to 2x minus 3y equals 9. All right, so let's see what this is all about. This is a linear equation. It's going to graph out into a straight line if we were going to graph it. To find the slope, we want to know what is the degree of steepness. All right, how steep is it? And also, what direction is it going in? So let's take a look at this problem and see what we're going to do with it. We've got, first of all, an equation that is in standard form for a linear equation. This is 2x minus 3y equals 9. Folks, we need to get to slope-intercept form. And a slope-intercept form means we would like to get y equals mx plus b. All right, we want to get y by itself, in other words. All right, that's where we're headed. That's where we're going. All right. And many of you go, oh yeah, we've done that some. Yes, we have. You've gotten variables by themselves. And in this case, we've got two variables to worry about. We're going to worry about getting y. Again, the y by itself. So let's see. I'm going to rewrite this while you're rewriting it at home. Maybe some of you will be. Let's see what happens here. First things first, I ask myself, what's keeping me from having y by itself? Well, I see a 2 and an x. They're attached together, so we can get rid of them in one fell swoop. And I've also got this minus 3 that is a pain waiting for me to go away, all right? So we'll get working with that too, but we're going to work with the 2x first because it seems to be further away and it's easier to remove. Now, the 2x is positive. It is positive, and I want to move it over to the right-hand side, all right? So let's subtract 2x off both sides here. Minus 2x. Be careful when you do this kind of manipulation. Don't do 9 minus 2 here. That isn't what we want. All right, we want to just get rid of the x's here. We're going to have a minus 3y left to the left on the left-hand side. And on the right-hand side, we have equals to a minus. Keep that minus there. I'm about to blow it there. Minus 2x plus your 9. Plus your 9. That is a negative, folks, in case you're wondering. Those of you just tuned in. Negative 2x. Big negative 2x. How's that? Now, what's going to happen is we have to remove this negative 3 out of the picture. It is hooked in by multiplication. So let's take care of that. We'll divide by negative 3. By the way, that's a negative 2 still hanging around there in case you're just joining us. And we lose the 3's here, and we lose the negatives. That gives us y, and that's important, okay? And I got y equals 2/3 x plus, what's going to happen here? We'll put a negative 3 on the end there. We could put a big minus 3 there. But that tells me the intercept is at negative 3. We're talking about finding a slope that is perpendicular. So right now, folks, in this problem, we have m as 2/3, and we have that intercept at 0, negative 3. Now you say, well, Ernie, it says perpendicular. If it said parallel, there would be your answer right there. If it's parallel, it means those lines go in the same direction, one way or the other, maybe up and down, maybe up horizontally, but they're all parallel. They never intersect. That means they have the same slope. This is not that case. We want them to make right angles. We want to make right angles right there in the middle somewhere. So what we need is the opposite reciprocal. The opposite reciprocal. So first of all, we get 2/3, and we take the reciprocal, which would be 3/2. But the opposite means change signs. Now this one happens to be positive, the way we have it. So we're going to look at negative. So our new slope, our perpendicular, by the way, we use this upside down t for perpendicular. Our perpendicular slope is going to equal negative 3/2. That'll be what it'll be. Which means basically when you try to graph with that, it's going to be going down 3 to the right 2, whereas over here we were going up 2 and to the right 3. So it basically twists and turns it around. Now, I have a lot of times people like to say, what does it look like on a graphing calculator? So let's take a look at this, all right? Let's go to the y equals keys, and you all got your calculators going on there. Let's do y equals there. And according to this, I don't have anything in the thing yet, so let's put something in there. Let's use that first one we had, that 2 divided by 3, attach an x with it, life is good, and put the minus 3 on there, all right? This should give us a nice linear graph. Let's check it out right here. There it goes. Boom, 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 boom. There's your first graph. Now, we would like to show something that has a negative 3/2. We want to see how they relate together perpendicular. So let's put that negative 3 divided by 2, and be sure, dear friends, you attach an x. Because if you don't, you're going to get a horizontal line, which is not what we want here. We don't want a flat line. We want a diagonal looking line, okay? So let's graph this and see what happens. There's our second graph. And there it came through. Man, it came through at a pretty nice right angle. You know why? Because I had zoomed that thing You have to zoom 5 to make it work like that. But let's see what happens. There goes the first line. Here comes the second line. My goodness, that is beautiful. Look at that right angle. 4 of them, 4 of them. That's how we know we have perpendiculars. They make right angles, okay?
For more math help, visit TNLearn.org.